Alkyne can be reduced to alkene by catalytic hydrogenation. Utilizing hydrogen and a metal catalyst, here platinum or palladium or nickel, you generate this cis alkene as the reaction intermediate, followed by further hydrogenation, essentially generating an alkane. The reaction almost never stops at the stage of alkene. In fact, the alkene is even more reactive toward the catalytic hydrogenation reaction. In order to stop the reaction at the stage of alkene, we could treat the metal catalyst. For instance, you could treat the palladium by coating it with a barium sulfate in quinoline, and by doing that, you poison your catalyst, and for this combination, it's usually referred to as Lindlar's catalyst. And by doing that, your hydrogen would be added onto the carbon-carbon triple bond, again in a cis manner, generating this cis alkene, and the reaction will not go along to further reduce this cis alkene to the alkane. What if you want to prepare a trans alkene? To prepare a trans alkene, you could treat your aldehyde with sodium or lithium, with ammonia or ethylamine in low temperature. Eventually, you can generate a trans alkene. The reaction really undergoes by single electron transfer mechanism. When you dissolve sodium in liquid ammonia, sodium would dissociate, give out an electron, and the solution actually turned blue. And this electron could be donated and pair up with an electron on the pi bond, and the other electron on the pi bond is shifted over to the orbital of the other carbon. Notice here I'm using the fishhook arrow describing single electron transfer. You're generating this radical anion reaction intermediate. This radical anion reaction intermediate could quickly react with the ammonia and through a Bronsted-Lowry acid-base reaction and generating a reaction intermediate like this. This is a vinyl radical. And this second step, let's number this as step 1, step 2. This second step really is important because through the second step, you may generate two different vinylate radical. One vinylate radical is Z. Let me put the unpaired electron in the orbital, okay? And it's a Z radical compared to a E radical, and the E radical is more stable because the bulky group R are further away from each other. Instead of over here, the two bulky group could have steric hindrance. Under that circumstances, because the E is the major, reaction intermediate, and the E would undergo another single electron transfer over here, and essentially you generate another vinylate anion. And this anion could be further protonated, essentially generating the trans alkene. So by doing this, you're generating the trans alkene.